episodes. This is the second of the 7 classes that we have today. This one is going to be DNA Basics, an Introduction to DNA and Genealogy, and it's being presented by Beth Taylor. We just have a couple of housekeeping items to go through. We've created a wiki page for today's class content, where all of the handouts are for the individual classes. And I'll post that link into the chat momentarily. We're going to do a Q&A at the end of each presentation. So please post your questions into the chat or comment section. And regardless of what platform you're on, whether you're joining us on Zoom or StreamYard, we're going to try and answer all the questions. If you need help with a specific DNA research problem, we encourage you to sign up to meet one-on-one with one of our research specialists in a free 20-minute virtual consultation. Go to the Family Search Library's website at familysearch.org/library and click Research Help. If you want to view upcoming webinars taught by the Family Search Library, go to the Family Search Library's Classes and Webinars wiki page. And the recordings of today's classes are going to be found on our Facebook page, and then we're going to put them on our Roots Tech page. So let me introduce the presenter for our next class, Beth Taylor. Beth is a certified genealogist and works as a United States and Canada research specialist at the Family Search Library. She holds a bachelor's degree in history from Brigham Young University and has worked for Family Search for over 15 years. Her specialties and interests include DNA, Quakers, land records, probate records, organizing, and more. So now I turn the time over to Beth.
Thanks, Tanner. Hopefully you can hear me okay. So Tanner, jump in and tell me if you can't. But now that we've done a really fascinating case study that Jeff presented for us, we wanted to take a step back and just go through some of the basics of DNA to kind of remind ourselves, give us that foundation. And for those who are a little bit newer to DNA, give you some kind of background on just the basics of DNA. Okay, so like Tanner said, I work at the Family Search Library. I'm a US-Canada research specialist. So whereas Jeff could tell you a lot about Sweden, I can tell you a lot more about the United States. So my objectives today is we're going to start by asking the question, what is DNA? Then we're going to talk about why DNA is valuable for us as genealogists. We'll go through the types of DNA that are used by genealogists. We'll look at what kinds of results you get when you take a DNA test. And then we'll go through some testing companies and the resources that they offer. So again, we're just kind of doing a good overview. So let's start with the question, what is DNA? DNA is an acronym. It stands for deoxyribonucleic acid. Now, I always tell everyone that you practice that once, impress all your friends, and then forget it. Because really, it's not as important what the acronym stands for. What we really want to know is, what is DNA itself? So DNA is actually the genetic code that defines who you are. It defines your biological characteristics. DNA itself is made up of what are called bases or nucleotides that are paired with their counterparts, and then they're kind of twisted into what we know as the double helix. Now, there are 2 types of DNA that we use for genealogy purposes. First, we have the nuclear DNA, and this is DNA that's found in the nucleus or the center of most cells within your body. In these cells, those base pairs that we're talking about, the nucleotides, are actually coiled, kind of smashed together into packages that we refer to as chromosomes. So those chromosomes, you have a total of 46 chromosomes, 23 paired chromosomes. So they're kind of got a counterpart. Out of those 23 pairs, 22 are known as autosomes. And we want to keep in mind this term autosomes because later we'll be talking about something called autosomal DNA. So autosomal DNA consists of the 22 paired and they're numbered autosomes. And then the final pair of chromosomes are the sex chromosomes. You can either have an X and a Y, or you can have two X's. And if you have an X and a Y, you're biologically male. And if you have two X's, you're biologically female. So kind of just the basics of what that DNA is, because we use these terms a lot as we talk about DNA for genealogy purposes. So this is actually a picture from an electron microscope from the National Institute of Health here in the US that just kind of shows what the chromosomes look like when you look at them up close. So again, it's all of that DNA smashed together or coiled together into packages called chromosomes. The other kind of DNA that we talk about for genealogy purposes is mitochondrial DNA. Mitochondria are actually located outside of the cell's nucleus, and they're the cell's powerhouses. They have their own unique DNA. And the mitochondria, there's actually multiple copies of the mitochondria throughout this cell. So each cell only has, one nucleus with one copy of the DNA, whereas there's multiple mitochondria, so multiple copies. So sometimes it can be easier when they look at historical remains to test mitochondria. But again, the mitochondria have their own unique DNA, and we do test mitochondrial DNA, and we'll talk a little bit more about that in a minute. So again, two kind of locations that we're looking at for DNA, one in the nucleus and one in the mitochondria. So that's about all I feel like you really need to know biologically about DNA. There's a lot of great content if you want to know more about the ins and outs of DNA and what it looks like. But really for genealogy purposes, if you know that much, you're kind of got enough to get going and start using the DNA to help with your genealogy research. So the next question I like to ask is, why is DNA valuable to us as genealogists? Why do we want to use it? And there's two things I like to think about with DNA. First off, DNA is valuable because it's inherited. I actually really love this idea that I'm spending my time looking for my ancestors and trying to figure out who they are. And a part of my ancestors is actually inside me. It's part of me already. So it kind of gives me this biological connection to my ancestors. But because I inherited it from my ancestors, I can use it to hopefully help identify who those ancestors are. So your DNA is inherited kind of along specific routes. From your dad, you get 22 autosomes. We talked about the 23 paired chromosomes, and 22 of them are numbered autosomes. So you get 22 autosomes. And then if you're biologically female, you get an X chromosome from dad. And if you're biologically male, you get a Y chromosome from dad. From mom, again, you get 22 autosomes. So you get half of your DNA from dad and half from mom. Just that's automatic. From there, it's a little bit more random, but for mom and dad, that's the way it works. And then for mom, everybody gets an X chromosome because your mother is biologically female, meaning she has to have two X chromosomes. So she can't pass on anything other than an X chromosome. And then your mother also passes on mitochondrial DNA. So that mitochondrial DNA, everybody has mitochondrial DNA, but it is inherited along the female line from your mother to her, that came from her mother, and so forth. So again, DNA, we use it because we're looking for our ancestors, and we inherited DNA from our ancestors. So kind of think about, here's you and all of your DNA, and your DNA is kind of a mashup of the DNA from your parents, your grandparents, your great-grandparents, and so forth. So that your DNA, you are kind of, you're again inheriting that DNA from your ancestors. The other way that DNA is valuable is when we compare it with somebody else's DNA. Your DNA by itself doesn't tell us very much. If we just look at your DNA, that's awesome. But unless it's compared to somebody else's DNA, there's not much value in it by itself. So this is why DNA becomes really valuable when we look for people in databases who've also taken a DNA test. For those who watched Jeff's class earlier today, and if you didn't get a chance, I would suggest that you go back and watch it. He talked about the importance of finding the testing company who provided more DNA matches. More DNA matches, again, you have more people to compare against. So the kind of basic idea behind testing DNA is that if two people take a DNA test and they share DNA in common, meaning there's segments or lengths of the DNA that are identical, that means there is a relationship. So based on the amount of DNA and how many segments, most of the DNA companies will predict a relationship. But at that point, all the DNA can do is say there is a relationship between these two people, and we think the relationship is maybe, a second or third cousin. But what that relationship actually is can only be verified or proven using records, or we call paper trail research. So DNA will go hand in hand with traditional research at this point. We don't have a way to just take a DNA test and build out your tree. So once that relationship is predicted, you compare family trees, and your goal is to identify the most recent common ancestor, meaning, or the MRCA, meaning the ancestor that you share in common, or the ancestral couple. So again, DNA is valuable because we inherit it, but it's also valuable when it's compared. So if you're not finding solutions to your problems using DNA, a lot of that could be because there's nobody else who's taken a DNA test, whether that's with the company or just taken a DNA test at all, to compare with. And if there's nobody to compare with, it's a lot harder to use that DNA for genealogists. So kind of think again, you have DNA and your cousin has DNA, and what you want to do is compare it and see what overlaps, or in this case, see what colors are the same. But it's, your DNA is not quite colored, but same kind of concept. Okay, so we've addressed what is DNA. DNA is your genetic code. We've talked about why it's valuable, because it's inherited and when we compare it. Next, let's talk about the types of DNA that we use for genealogy research. And I just want you to keep in mind, we tend to focus a lot on one type, which is autosomal DNA, but there are other types of DNA that might help out. And Jeff mentioned this earlier, the importance of working with Y-DNA. And I know there's a class later today that Tanner's going to present just on Y-DNA, so you'll get more there. Let's start with Y-DNA. Y-DNA is testing the Y chromosome. Now, if you go back, we talked about the Y chromosome is only carried by men. It's one of the two sex chromosomes, and it's passed from father to son. So if you have a Y chromosome, you inherited that from your father, who inherited it from his father, who inherited it from his father, and so forth. That Y chromosome is inherited virtually intact, which is the only chromosome that doesn't recombine because it has nothing to recombine with. So the idea is that you can compare the Y chromosome of two different men who've taken a Y-DNA test and determine if they have a common patrilineal ancestor, meaning an ancestor along that paternal line. Now, when you do a comparison for most of the time with Y, and again, come to Tanner's class if you want more details, the idea is that if the larger genetic distance, meaning the more differences between the two Y chromosomes, the common ancestor tends to be further back in time. And the way the Y chromosome is tested, at least the beginning tests, so if we're not talking about the big Y, they test what are called locations or markers. They'll say it's a 37 marker test. They test those and again, compare them with other men who've taken a Y-DNA test. Now, if you're female, you're a woman, and you're saying, well, how is Y going to help you? What you need to do is to start doing targeted testing, where you go out and find men who carry the Y that are going to help you with your brick walls, with your research questions. So if you're looking at your fan chart and you're, again, biologically male, this is the ancestors that Y chromosome relates to. So if you are working on a research project along this line, then Y-DNA may be helpful, may be beneficial. So to kind of give you an example, now I'm female, so of course I couldn't test myself for a Y chromosome, but I went out and talked to my dad and I tested him instead. So my surname is Taylor, and here are the matches for my father. And you'll notice that the first four matches all share the surname Taylor, which is probably a good sign that the Taylor surname, there's not a break in the line somewhere. And a way that I can use the Y-DNA, because Y-DNA kind of stretches further back in time than other kinds of DNA, meaning we can use it for questions further back in time. to kind of give you a little bit of history on my Taylor line, we've traced the Taylors back to a man named Peter Taylor. What we know about Peter is he was born about 1660, and he was of Parish Sutton, and what of means he lived there at some point in Cheshire, England. And we know that he died in 1720 in Chester County, Pennsylvania, and he was a Quaker or a member of the Society of Friends. Now, at this point, we've somebody, not my family directly, but I found a book. Somebody hired a researcher in England and who went and looked at the records of Parish Sutton and in surrounding areas. And what they discovered was there was a Quaker enclave there. And it seems likely Peter was born somewhere else and had moved to that area in order to join the Quaker enclave. So we don't really know where he originated. So we're kind of at the point where the next step in the research is to kind of look at all of the Taylors in England, which has never really been one of my highest priorities because honestly, the number of Taylors, men with the surname Taylor in England, is going to be a lot. However, DNA can actually help out by suggesting a relationship. So two of the matches to my dad both descend from a man named Christopher Taylor. And Christopher Taylor, according to the records, I need to still verify some of this, but the records claim he was christened on the 15th of February, 1624 in All Saints Parish, Yorkshire, England. But he also died in Chester County, Pennsylvania. He was also a Quaker. He died in 1686. So it looks to me, because the descendants of Christopher and the descendant of Peter, my dad, match on their close matches on their DNA, it suggests to me that Christopher and Peter were related to each other. So I can now go back, because Christopher has a specific location in England where he was christened, then I can go back and see if I can find records of Peter in the same area. And my theory right now, I haven't put the time into it yet, is that Christopher is Peter's uncle, because age-wise, he's a different generation. And that partially that's because when they came to Pennsylvania, they did not settle in the same area of Chester County. They didn't settle near each other. And I kind of concluded that if they were father-son, that they would. But it's possible they are father-son as well. But again, that's up to me now. I get to take the paper trail research, the records, and go see if I can find Peter Taylor being born near Christopher. And I'm lucky that I also know Peter had a brother named William who immigrated at the same time. So this is, again, a way that we can use DNA, is sometimes DNA is suggesting relationships. It's pointing out, it's giving us a direction in our research, but the paper trail is never eliminated. You still have to use that paper trail to help. Okay, so that was Y-DNA. The next kind of DNA that we use is mitochondrial DNA. We talked about the mitochondria earlier. The mitochondria fit outside the cell's nucleus. They have their own unique DNA, and they're passed from mother to her children. So everybody has to have mitochondrial DNA, but it is inherited from your mother, who inherited it from her mother, who inherited it from her mother, and so forth. So like Y-DNA, you can compare the mitochondrial DNA of two people, determine if they have a common matrilineal ancestor. However, mitochondrial DNA does mutate slower, meaning there are fewer changes that happen on an ongoing basis, which means that you can get matches, people that look, have identical mitochondrial DNA, and the common ancestor can be further back in time. And then, of course, the other issue for a lot of cultures that take the father's surname, the children all take the father's surname, is it's a little trickier to trace the mother's line just because of the surname changes. But like Y-DNA, they do a comparison and they give you something called a genetic distance. In this case, the larger the genetic distance, the common ancestor is further back in time. So if this is your fan chart and your research question is on this specific line in your fan chart, whether you're male or female, doesn't matter, then you can use mitochondrial DNA to help with that research project. One of the examples I know of where mitochondrial DNA was used was in identifying the remains of Richard III. Richard III has a bit of a bad reputation. He was one of the kings of England, but somebody wanted to figure out where he'd actually been buried, so they tracked where they thought he would have been buried, which is now a car park or a parking lot in England. So they found some bones. They said, is this Richard III? And they did a lot of tests in addition to this, but one of the ones they did do was testing the mitochondrial DNA in the bones. They also identified the descendants of Anne of York, who was Richard's sister. So remember, Anne would have shared the mitochondrial DNA, and her living descendants along the female lines would also share her mitochondrial DNA. I believe they found 4 descendants. They tested them and they did match. So they used that match, that mitochondrial DNA match, along with a lot of other evidence to confirm that the bones did belong to Richard III and that they had located them. Okay, the next type of DNA that we want to talk about is autosomal DNA or ATDNA. This again is the DNA, that's why we talked about the 22 pairs of numbered autosomes. That makes up our autosomal DNA. So those, again, the numbered chromosomes are what are called autosomes. Remember that one set of autosomes is inherited from mom and one set from dad. However, before you get what you get from each parent, the DNA it goes through a process called recombination, which means that you don't get a quarter of your DNA from each grandparent. So you'll get like different percentages from each grandparent, not an exact quarter. So it's only at the parent level that you can say you got half. From there, it gets to be a little bit more random. There's a lot of randomness in inheritance. Autosomal DNA is useful for the last 5 to 7 to maybe 9 generations, but the more generations you go back in time, it's a little bit harder to use. And keep in mind that as you go backward in time, you just cannot have DNA from all of your ancestors. That, if you're going 10, 15 generations, you're only getting half at each level. And at some point, some of your ancestors fall off your genetic tree. Now, you're also only guaranteed to share autosomal DNA with a second cousin or closer. This is going to be really important if you're saying, okay, this person is a second cousin once removed, and we don't share DNA, so that means we're not related. It actually just means you might not have in order to show up as a relative or as a match on the DNA testing companies, you and your cousin have to both have inherited DNA from the common ancestor, and that DNA has to be overlapping, meaning it has to be DNA in the same place on the chromosomes. So if it's not, you can both inherit from the common ancestor, but it's not matching, it's not overlapping, you don't show up as matches. That doesn't mean you're not related. It just means that there is no overlapping DNA. And that happens, especially as you go further back in time. So just keep that in mind. It's only a second cousin or closer that you are guaranteed to share DNA with. Autosomal DNA is measured in something called centimorgans, which is a kind of a complicated, it's about probabilities and things. And I just like to say it's a unit of measurement. And the more centimorgans you share in common, the closer the relationship is kind of the basic theory. So just as a reminder, you have a genealogy tree, but you will also have what's called a genetic tree where some of your ancestors, you just don't have any DNA from those lines. Again, just because you can only get half at every generation. So using autosomal DNA, this is the big DNA that we use. Most of the DNA testing companies only test autosomal DNA. This is what we're all using for the most part when we do DNA testing for genealogy purposes. So when you use autosomal DNA, what you're going to do is get what are called matches. A match is just somebody that you share DNA with, that there's some overlapping segments, meaning the codes are identical for both you and your cousin. So here's an example of a match. I believe this comes from family tree DNA. According to this, this is actually a match between my father and one of my coworkers' mothers, her mother. They turned out to be matches DNA-wise. According to the DNA testing company, they share 46 centimorgans, the longest segment being 19 centimorgans, and they predict the relationship to be 3rd to 5th cousins. Now, at this point, this is what the DNA testing company tells me, but I need to go out and look at my tree and look at the tree, or my father's tree, and look at the tree of my coworker's mother and find the common ancestor. So in this case, they both descended from a couple named Elias and Nancy, and it turns out that they're 3rd cousins once removed. So with using autosomal DNA, you'll want to get comfortable with those terms like what's a cousin removed, what's a half cousin removed. Those are terms that are going to be important with DNA because the more DNA that you share, the closer the relationship, but sometimes those relationships can be in different generations or be from a half relationship. Okay, so that's autosomal DNA. The last type of DNA that we will talk about with genealogy is xDNA. Now, xDNA is discussed quite as much, but just keep in mind that xDNA has a unique inheritance program. The way it's inherited is kind of unique. So again, xDNA is the X chromosome. It has that unique inheritance pattern. Everybody has inherited xDNA from their mother, because again, mom being biologically female only has X chromosomes to pass on. However, that X chromosome that you got from mom was recombined at the grandparent level. So it's a combination. I mean, it might not have been recombined. There are those cases, but just kind of keep in mind that you can get your xDNA from both of mom's parents. However, if you have an X chromosome from dad, and remember that's only if you're biologically female, do you have an X chromosome from dad? Because if you're biologically male, you got a Y chromosome from dad. Then that X chromosome cannot have come from your father's father, because that's a Y chromosome line. So it had to come from your father's mother. So if you have an X chromosome from dad, it comes from your paternal grandmother. So that's why we get this unique inheritance pattern, because xDNA is never passed from father to son. So if you share matching segments on the X chromosome, you do know that the common ancestor is along specific lines. And this is something you kind of have to think through, which lines can you get xDNA from. But there are some great fan charts you can just Google them. You can say xDNA inheritance. Or if you kind of look at this is a female xDNA inheritance for somebody who's biologically female, and somebody who's biologically male can inherit the xDNA from fewer ancestors. So again, just keep in mind xDNA might be helpful, especially if you're researching along these specific lines. Don't discount it, though not every testing company will tell you about your xDNA. Okay, so those are the different types of DNA that we look at as genealogists. Next, let's actually talk about what your results are. What do you get when you take a DNA test? And we're going to talk specifically about the testing companies who provide two big things, which are the ethnicity results in some format, sometimes called admixture, and then those that provide match lists. Because there's a lot of DNA testing companies out there that will just give you ethnicity, but we'll talk more about the testing companies that give you matches as well. Let's talk about ethnicity first. So ethnicity is just simply the percentage, I'm 15% Irish and 27%, Scottish and 5% British, or whatever your results are. And everybody gets different results with their ethnicity. Now, the ethnicity is determined by the DNA testing company going out and gathering samples from specific regions, and then finding what's common among all these people in these regions, and then comparing your DNA with those reference samples. So the samples come from around the world. Sometimes the different locations, the regions that they look at is growing. All of the testing companies are adding more regions, and so they're trying to get more refinement. And your results are just really how similar your DNA is to these reference samples. Keep in mind that the different DNA testing companies are using different reference samples, and they're also using different algorithms to determine your ethnicity, and so your results might vary from testing company to testing company. Ethnicity, I think, is a really fun, engaging way to look at your DNA. I think it can help when you have a research problem, especially if you're looking for your unknown father and you're showing up as really, really Polish, and you don't have any Polish on your mother's side. It can definitely give you some direction in your research, but don't put so much stock in your ethnicity that you're willing to cut people out of your life because the ethnicity doesn't work exactly the way you think it should. So keep also in mind that the ethnicity, the algorithms are constantly being updated. They're getting better. They're improving, so kind of watch for that. So let's take a look at an example. This is actually my ethnicity. So here's what my DNA looks like. It says I'm 97% European and 4% Middle Eastern. I'm very impressed I managed to be 101%. I'm not sure how that happened. You see kind of the breakdown, 43% Western and Central Europe, 39% Scandinavia, 15% British Isles. The thing that's always unique to me that here is the Scandinavian, since I have no known Scandinavian ancestors. But actually, that's what I looked like. That's what my DNA came back as of April 2016. In April 2019, however, my DNA had changed a lot. Suddenly, instead of being 15% British Isles, I was now 74% British Isles. And I had gone from being 39% Scandinavian to having no Scandinavian except for a trace of Finnish. So what's going on here? Is this my DNA is changing? I found a magic room that changed my DNA. In reality, this is just a sign that the testing companies, and this one, if you're wondering, is Family Tree DNA, is refining their results. They're trying to improve them. They're getting better. I actually think that all of them are getting better. They're more, detail oriented. They look more like what I would expect. And then here's what I look like as of April 2024. So I still do have a 7% Scandinavia, and the rest is supposed to be England, Wales, and Scotland, which does discount some of my ancestry, but that's okay. So just kind of keep in mind these will change over time. And that's, I think it's a good thing because the testing companies are improving. You can kind of see the same thing if you start comparing across the companies. This is again my results from Ancestry, from MyHeritage, from 23andMe, and then from Family Tree DNA. And you're going to see that they use, different combinations. Ancestry is combining England and Northwestern Europe, and then breaking out Scotland and Wales, whereas MyHeritage has combined Irish, Scottish, and Welsh into one grouping. So it's a little hard to compare across the board, but just keep in mind that, again, they're improving things, but it also means that things change. So it's kind of interesting to see what happens. Now, the other thing that the DNA testing companies will provide you with are the match lists. And a match list is just a list of people with whom you share DNA. So just keep that in mind. Each person's match list is different than every other person. And you'll even have a different match list than your siblings. The only way that you even could have identical match lists is if you have an identical twin, where your DNA is identical. On autosomal DNA, when you do an autosomal DNA test, which again, most of the companies, this is what they're doing is autosomal DNA test. The match list is ranked mostly based on the amount of shared DNA, with the DNA being measured in those centimorgans that we talked about earlier, with the higher centimorgans meaning the closer relationship. Y-DNA and mitochondrial DNA, it's actually based on what's called genetic distance, which is the number of differences between the DNA, sometimes also known as mutations. Just means, not that somebody's a mutant, but that one person, that you look at the two Y chromosomes and there's a difference or a change or, again, a mutation between the two. So it's the number of differences, meaning that you're looking for lower numbers when you're looking at Y-DNA and mitochondrial DNA, and higher numbers when you're looking at autosomal DNA. So again, with Y and mitochondrial, the lower the genetic distance, the closer the relationship. You're looking for, people at a genetic distance of 0 if you can find them. Now, as you look at these match lists, keep in mind that the basic idea of doing DNA testing for genealogy is that if you share DNA with somebody else, there is some kind of a relationship. Now, of course, you want to share enough DNA. If you were watching Jeff's class, he was talking about the importance of looking at, centimorgan counts, at least, 10 to 15 or higher, because anything lower can just be kind of noise. But if you do share DNA, you kind of conclude that a relationship exists. So you want to identify the relationship. And the way we identify the relationship is going, again, back to more traditional paper trail research. You can compare your family trees. If they don't have a good family tree out there, you can, send them a message and try and collaborate with people. That doesn't always work. You can do paper trail research. You can build out the trees of your matches. This is a very common approach to things. If people have enough in their tree to build it out, that's great. You can also use something called shared matches, especially with autosomal DNA. And you're going to see a lot of examples of that throughout the rest of the day, so we won't get into it too much. And then those relationships, like I mentioned earlier, are going to be described as cousins, cousins removed, and half cousins or half cousins removed. So if you're not comfortable with these terms, if you're not sure what the relationship is, just kind of keep in mind that that you'll want to learn this. And I know I'm going to go through this a little bit more in my class this afternoon. But just kind of keep in mind, here's, if we're saying John and Martha married, and they had children named William and Grace, and William had a daughter, Elizabeth, Grace had a son, Joseph, and then so forth. And then Martha married a second time to Frederick and had a daughter. Then we've got half relationships like Grace and Catherine are half siblings. You've got full relationships like Elizabeth and Joseph are first cousins. And then removed relationships are just when the two individuals don't have the same number of generational count back to the common ancestor. So like Elizabeth and Alexander are going to be 2 generations removed because Elizabeth and Anna are half first cousins and Alexander's a 2-generation count down from that. That's what we mean by removed. Not that we kicked the cousins out of the family, but that we actually literally just count that they're removed 2 generations from the level that Elizabeth sat. But so again, as you're working with your DNA and your DNA matches, you'll want to be comfortable with these terms and understand what they mean. Now, another thing that we can do, or what we can do then with our DNA, is there's a couple things we'll talk about. First is to solve genealogical problems. There's a lot of different types of problems that you can solve. You can identify biological parents and family members in cases of adoptions, when there's unknown parentage, so a situation where mom's not even quite sure who the parent is, or it's never been recorded, kind of like what Jeff showed us earlier today. We can also solve them in cases of what are sometimes referred to as either non-paternal events or misattributed parental events. These are events where the parent of record is not the biological parent. So a lot of times this does tend to be a father situation where the father of record isn't the biological father. And so we want to figure out who that is. DNA can also, it might not directly identify the person, but it might give us suggestions for further research. Kind of like what I showed you with my Taylors earlier, that DNA is pointing me in a direction. It's pointing what records I should search next. And then we can also use DNA kind of in an opposite way, where you put all the research together and hypothesize a relationship and then identify descendants of that relative, and do DNA testing to prove or disprove your hypothesis. So you can approach DNA in several, using DNA in several different ways. There's other things that genealogists are doing with DNA if you want to kind of get, try out some other things and play around with some other things. One is called chromosome mapping. And chromosome mapping is just figuring out which of your DNA segments came from which of your family lines. And there's a great website, DNA Painter, that will walk you through how to do it and help you get started if you're interested in pursuing chromosome mapping. And there are some other great tools out there as well. You can also join projects, which are really good for Y-DNA and mitochondrial DNA. Projects are usually just groups of people with similarities in DNA trying to figure out how they're related to each other. There's a lot of projects, surrounding surnames and other things that the people who run the projects tend to be very knowledgeable. So if you did a Y-DNA test and you're not really sure what it means, you can reach out to the project admin for one of these projects. Like I said, there's a lot of different types of projects. There's surname projects, like I joined the Taylor surname project, and it grouped me with a bunch of my father's Y-DNA with a bunch of other Taylors that seem to be related together, and then kind of separates other Taylors. So it helps kind of maybe disprove or separate out Taylors that aren't related to me, which is huge when you're working with a really common surname like Taylor. You can also join what are called haplogroup projects, and there's more information about haplogroups in your handout. There's even geographic projects where they're taking like the Isle of Man and trying to find descendants of people who live there so that they can see commonalities in the DNA from that area these are, again, another way to engage with your DNA. Okay, so we've talked about what your results, what you're going to get with your results. You're going to see a lot more throughout today. You saw some of that with Jeff earlier, and then with the remaining presenters, we'll talk more about how to use your DNA and how to work with it. So we won't go into more detail right now. Next, I just want to touch on the testing companies themselves. Which companies are we looking at to take a DNA test? And you really want to think of, again, we talked about the 4 types of DNA, the Y, mitochondrial, autosomal, and X. So if you want to figure out which type of DNA you're using, then you might need to then figure out which DNA testing company to use. So let's take a look at them. First, we have, Family Tree DNA. Now, Family Tree DNA is currently the only DNA testing company that's testing mitochondrial and Y DNA and providing match lists. So there are other companies that will test the Y and the mitochondrial and then tell you that they have a haplogroup for you. Haplogroup is just kind of like everyone has a common genetic origin, but they tend to be very, very ancient. So if you want the match lists where you can work with them and see those genetic distances, right now it is Family Tree DNA is the company you're going to want to test with. They also, of course, do an autosomal test. They refer to it as Family Finder. They provide ethnicity. They will give you a list of DNA matches, whether it's mitochondrial, Y, or autosomal. They give you some segment data, which is something you'll need if you're going to do chromosome mapping. They have something called a chromosome browser. We'll look at that in a second. Of course, they will provide you haplogroup info, and they have a lot of information about Y and the mitochondrial, the DNA tests and what you'll get from that. And then Family Tree DNA does tend to administer a lot of the projects. So if you're interested in joining a project, you'll probably want to start here. So this is an example of a chromosome browser. Before we had the option to look at what are called shared matches on most or in common with matches, that we were using chromosome browsers to try and identify common matches. But some people still really love the chromosome browser, and it is available from a couple of the websites. Again, it's just showing, so this is the gray is me, my DNA, and then the colors are two maternal aunts and a maternal uncle. So you can see where I'm overlapping with each of those individuals. Next up, there's 23andMe. I know there's some questions around 23andMe has been in the news a little bit because it's having a little bit of financial difficulty, but we're hoping it will pull out and still be a great company. But they do test just the autosomal DNA test, but they will also provide you haplogroup information for the Y and the mitochondrial. Again, they provide ethnicity. They'll give you your match list. But they also, and this is an add-on, this is going to cost you more, they will provide health data and predicted traits. They're kind of doing both genealogy and providing DNA for health purposes, which I think it's really interesting to see what they can do with that. And then one of my favorite things they will tell you is your Neanderthal percentage, what percentage Neanderthal you are. They have Ancestry DNA. They test just the autosomal DNA. They will give you ethnicity estimates like we were talking about earlier, but they've added something called DNA communities that actually tries to narrow down where you come from based on more than just doing these reference samples. It's actually a really fun thing. And I feel like they're a little bit more accurate than that, just the ethnicity by itself. So when they combine the two, you get some more specific areas. Of course, they'll provide the DNA matches. They're also providing something called through lines. Well, they'll try and figure out how you and all your DNA matches are related to each other. And they are introducing a lot of new fun tools with inheritance patterns and things from your parents. They're trying to separate mom and dad in your DNA results. So here's an example of the through lines. So they'll say, okay, this is an ancestor that you've identified or that we think should be on your tree. And here are all the DNA matches that you have that appear to relate to this ancestor. Note, however, this is always my one little caveat with all of this, is just that through lines is based on the trees on Ancestry. And as we all know, trees on Ancestry can be very, very accurate, and they can also be problematic. So don't rely exclusively on through lines. You're going to want to go out and prove it with records once the through line shows up. here's an example of that ethnicity inheritance, where they're trying to kind of break down my ethnicity and say, this is what I got from mom and what I got from dad. We also have MyHeritage DNA. They test autosomal DNA, ethnicity estimates. They do something called genetic groups, which is similar to the communities on Ancestry, also providing, again, DNA matches. And that we've got through lines on Ancestry, and MyHeritage does something called the theory of family relativity, and I'll show you that in a second. They also will auto cluster for you, and clustering is a foundational process that we follow when using DNA, which is clustering just pretty much is sorting your DNA matches into the buckets associated with your ancestors so that you can work with just the matches that are on the line you're interested in. And you're going to see that a lot today. So we won't go into it too much right now. And they also provide you with a chromosome browser. So here's an example of the theory of family relativity. And what they do is they'll try and take your DNA and then look at a match, and then they'll combine information from various trees to try and find the common ancestor for you. So in this case, this is a match. This is a match to me, and they use 3 different people's trees in order to try and find that common ancestor. So again, they're trying to help us. It's like through lines on Ancestry. It's a little bit different, but trying to help us out so you don't have to spend quite as much time going through the trees of your matches to figure this out. Finally, we've got Living DNA. Living DNA does just an autosomal DNA test. Again, they're going to provide ethnicity estimates. Living DNA is based out of the UK, and so one of the fun things they're trying to do is narrow down not just your ethnicity to England, but actually tell you which counties in England that ethnicity comes from. Again, like I said, they're doing UK regions. Like 23andMe, they'll provide haplogroup information for Y and mitochondrial, but they are not providing the match list. So that's the big difference between Family Tree DNA and the other companies. Again, they're providing DNA matches, family networks, and they are also, for an added cost, I should tell you this, they will tell you your Neanderthal and Viking percentage. So just kind of some fun information if you want to take a look at it. So those are the 5 big DNA testing companies that we talk about the most. And the reason we focus on them is because they provide the match list as well as the ethnicity estimate. Like I said, there are a lot of resources out there that will give you an ethnicity estimate, but they might even give you haplogroups, but they're not providing you with a list of matches. And what you'll see is the ethnicity can be helpful, but really it's that match list that's the most valuable part of using DNA for genealogy purposes. So let's kind of end the class just by talking about some other resources that can be helpful that you'll want to be aware of if you haven't played around with them. Let's start with GEDmatch. GEDmatch is kind of trying to solve the problem. What if you take a DNA test at Ancestry and your cousin takes a DNA test at 23andMe? How do you compare? How do you work with the DNA? So GEDmatch said, we'll build a tool where you can both upload your DNA and we'll compare. So GEDmatch doesn't test itself. They don't do any testing, but they'll allow you to upload your results from any other company, and then they'll do comparisons for you. So there's a lot of great tools. Some of them are free, and some of them there's an additional cost for them, or a cost. So you can kind of play around with it. They have some admixture tools. Admixture is another term for ethnicity, but it's based on some scholarly works, which are kind of fun to play around with. They have, again, similar to the match lists on other websites. You can compare 1-to-1 and 1-to-many. You can compare multiple kits. So if you're kind of, you've got 5 descendants of the same brick wall ancestor and you want to do some comparisons, you can do that. You can review the matches in their database. They have a ton of fun tools. They have something called the Lazarus tool that will let you take, the DNA of like 4 or 5 siblings and try and reconstruct the DNA of their parents. So if your grandparents are deceased, maybe you can at least kind of come up with a kit for them based on the siblings. There's just a lot of fun tools at GEDmatch, so something to play around with. DNA GEDcom also has a lot of great tools that can gather your DNA from the other websites and do a lot of comparisons. Again, like GEDmatch, there's some free tools, but there's also some tools that cost money or that, are more subscription tools, but you can compare a lot of DNA data. You get some more refined segment analyzers and something called GWorks that compares GEDCOMs. There's just, again, a lot of things that DNA GEDCOM offers. So again, they don't do DNA testing, but they will help work. They'll let you work with your DNA data. DNA Painter is another great resource. They kind of started DNA Painter as a chromosome mapper, but then they've also are hosting what's called the Shared Centimorgan tool. I'm sure you'll see this again in later classes throughout the day. And they have a great tool called What Are the Odds, where you can kind of build out a hypothesis of how you think you're related to a common ancestor. You've got that brick wall, but you have all these relatives. You can kind of build it out and hypothesize, and it will help guide you to kind of figure out which line you're connected to. It's a great tool if you haven't played with it. They've introduced something called ancestral trees in the last year or so. And there's a lot more. Again, DNA Painter just keeps growing on a lot of these websites too. This is the Shared Centimorgan tool I kind of mentioned. This is one of my favorite tools because when you do a DNA test and the DNA testing company says, well, you and this match have 417 centimorgans in common, and we think that's a second to third cousin, or that might be closer. The problem is sometimes it's not specific enough what that means. And the Shared Centimorgan tool was actually an attempt. This is put together by Blaine Bettinger, and then Leah Larkin actually has helped make it available online on DNA Painter, working with the owner of the website. But you can actually come in here and put in the total number of centimorgans, and it will say that this is based on real data. Blaine went out and I think he's actually gathering data for another version. He's going to go up to version 5. But this is based on real data, meaning people have submitted saying, yeah, this is how much DNA I share with a grandparent, a great-grandparent, and so forth. And then he's brought all that data together. So you can kind of see what your numbers might mean within the larger scheme. So it's a great tool. If you haven't explored it, I definitely recommend that you take a look at it. It'll start helping better understand what those centimorgan numbers mean. Genetic Affairs is another website that they have a lot of tools, and they keep adding to the tools. You can retrieve new DNA matches. They have an auto clustering tool that's actually kind of the foundation of what MyHeritage offers, and much more. You can kind of see just even behind my little post-it note that they have auto fast cluster, auto segment, auto pedigree. They're just building great tools. For those who want to do genetic genealogy as part of your professional work, I would encourage you to look at the genetic genealogy standards. This link is in your handout. If you want to learn more about DNA, then definitely start with the ISOG Wiki, the International Society of Genetic Genealogists. This is a great wiki, has a lot of great information. If you want to learn more about Y or mitochondrial or X or anything related to DNA, this is a good starting point. Family Search has a whole DNA page. FamilySearch.org/DNA has a lot of information on it. And the wiki as well. We're starting to add more content to the wiki about doing DNA and how DNA works for genealogy research. There are some great books out there. These are listed in your handout, so I won't go through them. But again, something that if you need more help, you want more guidance, I would definitely take a look at these books as well. And I'm sure there's more that are being published that I'm just not yet aware of. So, okay, well, today our objectives were to address a couple things. We wanted to talk about what is DNA. DNA, it's deoxyribonucleic acid. Practice that one more time and then forget it. But it's our genetic code. We addressed why it's valuable, talked about how it's inherited and it's valuable when we can use it to compare. We compare with other people. We went through the 4 types of DNA, which are Y-DNA, mitochondrial DNA, autosomal DNA, and X-DNA. We kind of went through what you'll get when you take a DNA test, your DNA results, and some of what you can do with those results. And then we ended up by going through some of the testing companies and other resources that can help you learn more about DNA and genealogy. So any questions?
Yeah, thank you so much for that great presentation. There's a couple of questions that have come through in the chat, and if anyone has any more questions, definitely go ahead and post them, and regardless of what platform you're joining us on, we will get to them. Okay, so on Zoom, um, one of our guests asked, since DNA isn't male or female, and three people match me on the same segment, isn't it possible that some match me on my paternal line and some on my maternal line? They might not really match each other, even though they appear to be on the same segment.
So, and maybe Tanner, this is something you can, because so my understanding is it can be on the same segment, and obviously that segment, because that each chromosome you have one for mom and one for dad. Is the DNA are the DNA testing companies, separating that out well enough that you can distinguish between those two chromosomes, or they kind of just merge together? And that's a
Um,
question for you, Tanner, because I'm not quite sure.
yeah, the companies don't really have a way to separate your maternal and paternal chromosomes. So yeah, so some of those matches could be on your mom's side and some could be on your dad's side, and that would be why they would both match you in the same spot, but not each other. The other possibility is if one of them's a false positive, or if it's in a common pile-up region, which there's not very many of those, but those are just spots where like all Europeans match each other, things like that.
Yeah. So yeah, so it is possible if they're not matching each other and you want to check with them and see if they match each other, that they are just showing up because that it's the company can't really distinguish between the two chromosomes.
Right.
Great question. And I'm learning things too. Tanner's, I know a lot about DNA, but Tanner just knows quite a bit more than I do. So it's good to have him here.
Shelley says, I am female. Could I have X matches for my father's mother's mother?
Yes. So the key when you're trying to figure out if somebody that you could share X matches, it's just like you said, father's mother's mother. There's no two males in a row in that. So yes, if you're female, you can't have X matches from your father's mother's mother. But if there are two males in a row, like you're male, then you cannot. So that's what I always do is count the number of males in a row. And if there's two males in a row or more, then no, you cannot share X DNA. If there's not, then yes, you can.
Barbara says, Mom has two X chromosomes. Can she pass one to one child and one to another? Or is there some sort of rule like male children get one and female children get a different one?
No, it's very random. DNA, if that's the term that we use the most often, is there's just DNA and how it passes is all very random. So it is possible that mom has two X chromosomes and she gave one to one, that the two X's didn't recombine before getting passed, and she passed in. And I don't know how common it is for an entire chromosome to get passed without recombination. And so, but there is the possibility that one child got a complete Y or X by themselves and the other child got the other X. But again, all of the chromosomes tend to recombine. So it is way more rare, from what I understand. Tanner, correct me if I'm wrong, for chromosomes to be inherited intact like that. That there should be some recombination. So you would expect some overlapping between the two child.
Yeah. In the
But yeah,
case
one
of
of them, and one isn't marked as male and one female. It's nothing like that. It's way more random than that. Sorry, go ahead.
Sorry. Yeah, so in the case of the X chromosome, you've got about an 85% chance of getting a mixture where it's recombined, and you've got about a 15% chance of getting it passed down intact from just one of them. And so the situation that you described, where one child has one and the other has the complete opposite one, can happen about 1% of the time. Um, let's see. Marcy says, do you need to get a special DNA test to do mitochondrial or Y-DNA results?
Yes. So it'll still come in, it'll still have the same packaging. I shouldn't say it's a special DNA test. It does have to come from family tree DNA. And you can provide one sample, and oftentimes they'll be able to do both the Y and the mitochondrial and even the autosomal off of one sample. Though sometimes, yeah, you actually give them, I think you scrape twice with the family tree DNA, at least I have. It's been a few years. So yeah, it's not really, it's just a different company than most people go with. And like I said, one sample can test for all three if there's enough DNA. So I guess it's not quite a special kit, but you just want to make sure that you order it that way so that because you always pay for the test before you get the kit. I hope that answers your question.
Yeah, that's a great answer. So if you have a deceased if you have somebody you've tested at Family Tree DNA and they've since died, I would recommend just giving them the full treatment. Like give them the autosomal, the big Y, the mitochondrial all at once, because they're storing that spit, but once it runs out, it's gone. So
Yeah.
Okay, so Mary says, how is there a large database for Y DNA?
Well, if you're just talking about looking for match lists, because only Family Tree DNA is providing the match list, I think it's fairly large. I don't know that it's not going to come close to the size of like the autosomal DNA tests at Ancestry, just because it's not a lot of people. I shouldn't say not a lot. A lot of people test, but again, fewer people are testing the Y. So I don't know the size of Tanner. Do you? I haven't not ever looked at that, but you might know how many people have tested the Y family tree DNA.
I know, I think it was last year they announced 100,000 big Y testers.
Oh
I
wow.
don't know how many there are for the others. I think the Y37 is a lot more popular.
Yeah. Well, I think because it's the cheapest. So every time you add on, there's the Y37 and the Y111 and then the big Y. And every time you go up to a bigger thing, of course, it costs more. So people tend to start with that Y37. So we do, but at last I heard, I think there was at least 1 million in the database, but you can always, who is it that likes to track numbers? Is it Leah, your
Yeah.
what is her website? DNA Geek?
I'll try and find it. Yeah, she's,
Okay.
yeah, DNA Geeks.
I think she said that look for the DNA Geek. She might have numbers for you.
Yeah. I'll
If you're
put
one of
that
those
in.
people that want some numbers, because yeah.
Um, I'll look for those numbers in a second. Gwen says, I get confused between Facebook groups for projects and the Family Tree DNA projects. If I join a Facebook project, what can I provide and ask for help with? Is it usually just like GEDmatch kit numbers?
I've actually never joined a Facebook project, so I'm not sure what they provide. I would definitely, find one and reach out to the person who owns it or post and ask for more information on what they're doing, what their goal is, what they're hoping to accomplish. Are they just comparing GEDmatch kit numbers like you said, or are they looking for something more? Um, but yeah, like I said, I just haven't participated in a Facebook group. I'm not sure, Tanner, have you?
No, I haven't. I don't really know what would be in one of those. Um, I think the Family Tree DNA group projects are primarily Y-DNA tests. So, um, okay, Shelley says, is there a relationship between the number of segments shared with a match and the number of family lines shared? If I share several segments, does that mean the match and I could share more than one family line?
So it definitely means that you could share more than one family line. It doesn't mean that you have to share more than one family line. Both of those segments still could come from the same family line. So if you share two segments, that isn't saying that that's coming from two different family lines or two different common ancestors. It's just saying you happen to share two common segments. So there, it is a possibility, but it is not a guarantee.
Okay. Um, Gerald on Facebook says, if you have two sisters married to two brothers, is there a way to search family tree and separate sides using DNA?
I think I'm a little confused by this question. So two sisters
Yeah.
and two brothers, then all of the children all have the same ancestors. So it does make it a little bit tougher to work with, but I don't know that there's going to be a simple way to separate the two lines because those children would all have exactly the same sets of ancestors.
Yeah, they'd
I
be
mean,
double first cousins, right? And so I think the
yeah, so
DNA would be higher.
they'd almost look like half siblings DNA wise, I would guess. I mean, since they're double first cousins.
Yeah.
But yeah, so I don't know that there's and DNA is going to really help distinguish which children come from which couple or anything like that. It's just going to muddy the waters a little bit.
Yeah. Jean on Facebook says, if I tested my father at family tree DNA at the Y37 level with no matches, should I bother with the big Y?
If your goal is to get more matches, you will not get more. I mean, if you've got 0 at 37, you're not going to get more by testing higher. But it doesn't mean that testing, the 111 down the road might be really beneficial if somebody else, because other people will test. You always get new matches popping up. But yeah, from what I understand, if you have 0 now, testing higher does not add more matches. It just helps filter down the matches you have. Am I right?
Yeah.
Again, Tanner, you're the Y-DNA. Tell me if I'm wrong on that.
Uh, that's right. I mean, selfishly, I hope you do upgrade to the big Y because the problem is we need more big Y testers. So if you upgrade, you're basically doing a service to the genealogical community, but you're not actually really helping your own problem in this scenario.
Yeah. But down the road, keep in mind, again, we're trying to get more people to test the Y, and the more testers we have, the more likely you are to get matches, and then you will want to have upgraded to a higher level to help you out with that.
Um, Aura says, on my heritage, what does medium confidence level mean?
That one I don't know. I would actually email or look at MyHeritage's help pages for that. I've never looked into their confidence levels and their meanings, but I'm sure they have a great help page that will give you that direction.
Yeah, it probably just means that there's a medium chance of it being a real match versus a false positive. But yeah, just based on whatever algorithms they're using. Um, let's see. Kathy says, had Y-DNA done with my father's first cousin once removed. Was this a valid test or was the DNA too removed?
It's a Y test.
Yes.
Yeah, a first cousin once removed, especially if your father's deceased, and you're pretty sure that they're are biologically should have the same Y. That is a very valid test, but you do want to make sure that there's no possibility that there's a non-paternal event going on in there. But yeah, no, that's a great test. That's especially, like I said, if your father's deceased and your father's first cousin is deceased, that's who you can get to do a Y, then that's awesome. You've got a good starting point.
Awesome. Um, let's see. Someone asked, how do you interpret Y-DNA results?
I think that's a great question for I would come to Tanner's class. Is it the very last class this afternoon? Why do your Y-DNA? He's, I'm sure, going to give you
Yeah,
some great tips and tricks on what to do with your Y-DNA testing. So I'm going to refer you to that class.
yeah, that'll be at 3:30 Mountain Time. So join us. Okay, so yeah, we've gone through all the questions. Just double checking and make sure there's not any more that are on some of the other platforms. If I missed anyone's question, just go ahead and type it again real quick.
I did notice a
There,
question in the chat that's about doing DNA on letters.
oh
Um,
yeah,
And there is a company out there, I'm not remembering their name off the top of my head, that is actually trying to do this. Is it called To the Letter? No, that might not be the right name. We'll find the name and put it in the chat. But yeah, there
yeah,
is one company out there that is trying to test DNA from stamps and letters and things like that. So
yeah.
I would work with them.
Yeah, there is To the Letter DNA. There is another company that they were at Roots Tech in 2023. And they were pretty much doing the same thing. I remember they were like a nonprofit based in like Salt Lake, and I have blanked out the name of them, and it just kills me because whenever people ask, I want to tell them that name, and I don't remember. It was another one besides To the Letter. Um, the thing I can tell you is that while it is possible, it is much more expensive. And so don't just think, oh well, I don't want to go take the time to visit them and buy a $100 DNA test for them now. I'm just gonna wait till they die, because it's like $2,000+ to try and get DNA from a letter. Um, let's see. Should
So
Carol? Oh, go ahead.
I was just going to say one thing I wanted to point out for those who are looking to buy a test is that this is the time of year to get DNA tests because they all go on sale around DNA Day. So definitely take a look at what sales are going on for the various companies. Sorry, and then there was another question.
Yeah, and I think this is um yeah, we got to give time for the next presenter. But Carol asks, should we do Y-DNA for both brothers of a son of an unknown father?
I think this is a great question for Tanner's class this afternoon. So come to his class and then ask it again, and if he doesn't address it, but yeah, definitely I'd refer you to his really awesome Y-DNA class.
Yeah. Okay, I think this is gonna be the last question that we have time for. But Mary says, family tree DNA lists genetic males receive an intermediate Y-DNA haplogroup that traces migration of their paternal line ancestors. If I have my father do this test, is it enough for paternal line, or should he just do the Y-DNA test?
I'm going to pass that question on to you, Tanner, because I'm not completely understanding what tests they're referring to.
Yeah, I'm not quite sure either. I think what they mean is, so if you buy a Y37 through a 111, they're going to just predict your broad haplogroup, like very ancient, like RM269, which basically just tells you where your ancestors were, like pre-pyramids. If you do a big Y, you're going to get a much more specific one. Um, could you and then Robert says, could you explain how to find a father from DNA matches if you get no responses? I think what you want to do, Robert, is come to our class that's starting in 1 minute called How to Build Quick Trees. So we're going to talk about that. But thanks everyone for attending. We're going to start our next class here in just a minute, and it's going to be how to build quick trees. Very important tool, especially when your DNA matches either don't have trees or they're not responding to your messages. I just posted the link to the handout in the chat for those of you who are on Zoom. But thanks again to Beth for an awesome presentation.